choose a word problem to work with. And also I would like to go through any of the problems that we see here. So I'm going to pick a problem, and then we're going to pick a word problem, and then move on. Okay, ready? Stop me if you have any questions anytime, you know that. And this is, I think it's 23rd already. Isn't it?
Yes.
Okay. Perfect. So let's look at 54 on page 755. And it says, find a line that is passing through -1, 3 and is perpendicular to the line whose equation is 3x minus 2y equals 5. Okay, so this is the scenario. I'm not graphing anything exact. I'm just giving you the idea. We have an equation. We have a line whose equation we don't have. But we are given two pieces of information about it. This is the first piece, and this is the second piece. The first piece says that the line passes through this point, which is -1, 3. The second piece of information says it's also perpendicular, forming, as we know, 4 90-degree angles, perpendicular to this line whose equation is given. Okay, so how do we determine this? Having two pieces of information, that's our question here. So I see y. I have two possible equations, right, to work with. Y equals mx plus b. No, because the given point is not 0, a number. The other option is y minus y1 equals the slope times x minus x1, as we know the point-slope form. Yes, I am going to use this one because I have the point -1, 3 because the point is on the line. So this is -1 and this is 3. The only piece of information that I'm missing is the slope. Once I get the slope, I plug it in and I'm done. But now the question is, how do I find the slope? I do know that two lines that are perpendicular have a relationship between their slope. Right? And the relationship is m1 times m2 equals -1. So this is the slope, let's say, m1, and this is the slope m2. This line has slope m1. This line has slope m2. Can I determine the slope of this line? Because if I have this one right here, then I can determine the one that I'm interested in. What did we do last time in order to determine the slope of a line? We had an example last time towards the end of the class. What did we have to do? What did we say? We have to do this in order to determine the slope. And what is that this that I'm referring to? Solve for? J? Right. We always solve for y, right? To determine the slope. If I solve for x, I'm not going to be able to determine the slope.
So you just move the x over.
So move 3x and also divide by -2. I have to have plain y, not -2y. Is everyone in on it? Do we understand this? Okay, so the equation we're given is 3x minus 2y equals 5. We are solving for y. Indeed, we are moving 3x to the other side. And remember, it's easier than writing minus, and so on and so forth. It's always easier to say this. If I'm moving a term from one side to the other, if the term is positive over there, it must be negative on the other side. That's all you need to do. And we recommend, of course, descending order. You can put 3x or -3x behind 5, but it's not the best idea. You want to keep it in descending order, like this. And now we divide by -2. Do not write this. It's not a good idea. divide each and every term by -2. So I'm going to write it again because I crossed it out. So -3x plus 5, we divide by -2. I put parentheses because these are two operation symbols. They have to be separated. And this is y equals 3/2 x minus 5/2. -3 over -2 is 3/2. 5 positive 5 over -2 is -5/2. Now I know the slope m1. Can anyone dictate the slope? Remember, the slope has nothing to do with x. It's just the number in front of x. Please, Maureen. Excellent. 3/2. Indeed. So if I have m1, which is 3/2, what should I multiply it by to get -1? Remember, it has to be this. If it's a fraction, right? It has to be this with the opposite sign. So what goes in there?
Minus 2/3.
Excellent. Only 3/2 times -2/3 will equal -1. So now I have all the pieces. All I have to do now, put them together. I have the point, I have the slope, I have to do rewrite, distribute, move 3 to the other side, etc., solve for y. That is important. We're going to do it in a minute, but I'd like to ask if you have any questions, were you able to follow this? Is that a yes? Do we understand what happens here? Or what just did? Yes?
I understand what we did for like, I forgot the question.
The question says this. Very good. It says find an equation. And we're given two pieces of information. One, there is a point that it passes through. And that point is -1, 3. And also the second piece of information is it's perpendicular to a given line.
So we have to find an equation.
We have to find the equation of the line passing to the point and perpendicular to that given line.
So the equation is y equals.
We haven't finished.
Okay.
It's all this. But we haven't finished. I just wanted to make sure that till this point everyone was able to follow.
So all we found was the slope.
Well, the slope, you can never determine the equation of the line.
I'm saying like what we did here for the problem.
Right now we found the slope, exactly. We were given the point. So the fact that the two lines were perpendicular, the slope was given indirectly to us. Instead of saying here, the slope is -2/3, they said, this line is perpendicular to another one. That's why we found the slope of the first line in order to find the slope of the equation we're interested in. So it was given to us in a roundabout way. Very good question, thank you. Okay, so let's finish it up. So here we have y minus 3 equals -2/3 x plus 1. Minus -1 is x plus 1. So I took the information from here, y minus 3. I copy -2/3, and x minus -1 becomes x plus 1. Now we have to distribute to -2/3.
So I have a question.
Please, Bob.
So the Pearson software seemed like it was kind of fussy about when you stop, because this right now the way you have that equation written, that is
In the point slope
in slope
form.
form.
I know.
And
I
so
know. I will never ask you to stop with the point slope form. I need y equals.
So you want us to drop the parentheses and multiply everything out.
So we will distribute -2/3 x, and -2/3 2x, and -2/3 to 1. Yes, please, Maureen.
Why did we use -2/3 instead of the 3/2?
The 3/2 is the slope of this line. m1 equals 3/2. We need to find the slope of the line that we are looking for.
So we're finding M2.
We need m2
Okay.
because m2 was not given to us. m1 was given to us, and in order to, these are not parallel. If they were parallel, yes, I would have used 3/2, but they are perpendicular.
Oh, so you had to multiply, cross multiply.
Yes. Yes, because they are perpendicular. Yes, perfect. Okay, and then plus 3. This gets moved to the other side. It was negative on one side, it will become positive on the other. Now we have to find the least common denominator here, which is, so I'm adding negative 2/3 to 3/1, and the least common denominator is very good. Only this one needs an adjustment. Because we multiply the denominator by 3, we have to multiply the numerator by 3. The negative always goes to the top. So it's negative 2 plus 9, which changes into 7/3. So the equation is this. So again, what is this equation? It's the equation of the line passing through negative 1, 3 and guaranteed to be perpendicular to the given line. Is that clear?
You said this equation is passing through negative 1, 3?
That was given to us from the very beginning. So this is the equation of the line that is passing through this point and guaranteed to be perpendicular to this line. Because we use this to determine the slope. By them being perpendicular, it helped us determine the slope of this line. So one more time, y equals negative 2/3 x plus 7/3 is the equation of the line that passes to this point and guaranteed to be perpendicular to 3x minus 2y equals 5. Better? Okay. Questions? If the question instead of perpendicular would have said parallel, we would have immediately used 3/2. This would have not come into play at all. We would have used 3/2, put 3/2 here, the rest would have been the same.
Would we still use the y minus y1?
Correct. Yes. Because we're not given, this point is not 0, a number. I cannot use this. If this, by any chance, is 0, 3, then I would have used this. Better? Perfect. Thank you for your questions. Very good. So now I would like to look at any word problem from here just to see how this works. It doesn't matter to me which one. Let's say the bar graph shows, this is the bar graph. So it says the bar graph shows the mean or average student loan debt in the United States. I don't even want to talk about it, but that's okay. In 2011, for your selected years from 2001 through 2010. Okay, so 2001 through 2010, and this is the average: 17,000, 20,000, 23,000, and it reached 26,700 in 2010. Okay, so here we are given the equation of the line that they came up with that represents or models the data. Shown to the right of the bar graph is a scatter plot with a line passing through 2 of the data points. Use the 2 points whose coordinates are shown in by the voice balloons to write the slope-intercept form of the equation that models the average student loan debt, y in the US, x years after 2001. So this is problem 69 on page 756. 69 on 756. Okay, so number one, I have to take, sorry. So number one, I have to take notes. So x is since they say 2001. So what is x? What for 2001, x has to be a particular number. What x represents 2001, and then y is student debt in US dollars, of course. So since all the information is referenced to 2001, what will x be representing 2001? Say it again. Yes, but how much?
Year 0.
Very good. If it says since 2001, it means that 2001 represents x equals 0. Agreed? Now we copy those 2 points. So the first point is 6, 23,300. And the second point is 3, 20,000. From left to right, I'm going to call this 1.1 and this 1.2. And it says, use the information to determine the equation of the line. So how do we start? First of all, I'm going to ask you, is any of the given points the y-intercept? Any of these two, is the y-intercept?
I'm not confused.
Okay.
They're both doing good. I'm not.
So what did we say was the y-intercept? What is the notation for the y-intercept? A point on the y-axis. What has to have for x?
Zero.
Exactly. We talked about that, right? The y-intercept has to have x equals 0. Does this point have x equals 0? No, that's why we couldn't use this. Any of these two has x equals 0?
It's hard to say because
Is x 0 in any of these points? What is x for this point? 3. What is x for this point? 6. Since this is not 0 and since this is not 0, we are not given the y-intercept.
I think it's the way you wrote it that made me confused. I'm thinking it's a whole amount.
Oh, it looks like 6 million.
Yeah, that's why I got confused.
But I have no choice. This is the way we write it.
I know, I'm sorry.
No, that's okay. So it's 3 comma 20,000, 6 comma 23,300. But it doesn't matter. This point, this x value is not 0. As long as it's not 0, it doesn't matter what it has, right? So this is an ordered pair. X is the first coordinate. This is the second coordinate. X is the first coordinate. This is the second coordinate. Is that clear? That this is not, we do not have the y-intercept. Agreed? Perfect. So what do we have to determine first?
Slope.
Of course. So the slope is y2 minus y1 over x2 minus x1, which is 23,300 minus 20,000 divided by 6 minus, it was 3. 20,000, 6 minus 3, of course. Be very careful. I messed them up by not writing them in the correct order. So 23,000 minus 20,000 over 6 minus 3. If you write them the opposite, but both of them, you'll still get the same answer. Okay, so the numerator is 3,300. The denominator is 3. So the answer is 1,100. 1,100 means nothing without the measurement unit. So I have to write the measurement unit. What does 1,100 represent? No. It's a rate of change. It has to have 2 measurement units. It has to have a measurement unit coming from the numerator and the measurement unit coming from the denominator. Please, Morgan.
Wouldn't it be like 20,000 minus 23,000?
23,300 minus 20,000. Isn't it 3,300?
Well, I thought Y2 was 20,000.
I messed them up by writing them in the incorrect order. So forgive me. 23,300. I'd rather go back and check. So even if it ended up not being a mistake, I'd rather go back and check. Whatever you think you see, maybe I don't see it. So it's 23,300 from point 2 minus 20,000 from point 1 over 6 from point 2 minus 3 from point 1. Is that better? So 23,300 minus 20,000 is 3,300. 6 minus 3 is 3. And 3,300 over 3 is 1,100. Measurement unit. What is the top measured in? Perfect. What is the denominator measured in? Very good. Per year. What does this mean since it's positive? It means that every year the student loan by exactly. Every year between these 2 years, between 2001 and 2010, when the study was conducted, it appears that the student loan went up by $1,100 per year. Perfect. So now I have y minus y1 equals the slope times x minus x1. It doesn't matter which point we use. Would you like to use point 1? Would you like to use point 2? Point 2. Which means that this is 6 and this is 23,300 and this is 1,100. Which means y minus 23,300 equals 1,100 x minus 6. Yes, I have to distribute. I have to move 23,300 to the other side and combine like terms, simplify fully, and then answer part B. And let's see what part B is telling us. So y equals 1,100x minus 6,600, but plus 23,300. So y equals 1,100, and then plus, I think I have 7, 0, and 6 from 22. Correct me if I'm wrong. Let me know if this is correct. Part B. If trends shown by the data continue, use the model from Part A that we just determined to project the average student loan debt in 2021. What does 2021 represent for us? Are my numbers correct? Please correct me anytime. Perfect. So what does 2021 mean? Remember what we said about x. 2001 represented x equals 0. What about 2021? So I'm going to write it here. X equals 0 for 2001.
Can you show us the original chart again?
Yes.
So that the 2021 is outside the bounds of the original data system.
Very good point, but that's what it says. If trends shown by the data continue.
Right.
We don't know. Yes. Say it again. Go ahead.
I was going to say if X changed to 21,
We cannot use the name of a year. We did not use the name of the year.
So year 0 was 2011. So year 2021 was year 10.
So 2001 was 0.
Oh, it was 0.
So then for 2021, X is?
20.
Is that clear? Perfect. So all we have to do, y equals 1,100 times 20 plus 16,700. And if the trend continues, I hope not, but if the trend continues, please give me that number so we can move on. Next step is 2.1 and 2.5. Do we have the number? So 2,200 and 16,700, I got 1,890. And this is US dollars. Any questions? Say it again.
That can't be right. Because 1,100 times 20 is 20,000. It's more like 38.
Oh, I missed a 0.
38,000.
I missed a 0. Thank you very much. 0, 0, 7, 8, and 38. Yeah, I missed a 0 here. Thank you very much. 38,700. Is this okay? Was this the confusion? Okay. Bad numbers. Good. Keep me on the right track. Okay. Moving on. We are continuing with sections 2.1 and 2.5. That's where we are. Whoever had this idea of loose leaf was brilliant. Whoever put it in practice, I don't know what to think about that person or person. I guess it may be a good idea. Okay. 2.1 and 2.5. Basics of functions and their graphs. We're going to look at a lot of things here. Ready? 2.1 and 2.5. So we're going to start with 2.1. Functions. Okay, I'm going to create a couple of sets of bubbles. 3 sets of bubbles, of pairs of bubbles. And I'm going to pick some numbers in the first bubble. Let's say x equals -1, x equals 2, x equals 0. And I'm going to say they correspond to y equals 0, y equals 3, y equals -1. In the same way, I'm just going to point out different connections. Just imagine there are some numbers in there. And here's another situation. So 3 possibilities. The first set, for all of them, represents values of x. X values for all first set. First set is the values of x, first set values of x, first set values of x. Of course, the second set represents values of y. Values of y, or y values. Same thing here, y, same thing here, y. These 2 sets have special names. We normally call them domain and range. Domain, domain, range. For all of them. Where we pick x is called domain, where we pick y is called range. Now, from these 3 scenarios, let's analyze each of any one of them and identify which ones are functions. And then we'll talk about the definition of a function. Okay, so I see that x corresponds to only one y value, this x to only 1, and this x to only 1. This is the concept of a function. Function. Each x corresponds to only one y value. And the notation, it depends. It can be a lot of things. It can be f of x. It's not f times x. It's not f parentheses x. We read it f of x. But it can be, let's say, p of v. It can be t of t. Like a temperature of time, so temperature function of time. Or, I don't know, pressure function of volume. So obviously this first one is a function. One more time. Each x value corresponds, L-U-E. Each x value corresponds to only one y value. That's a function. That's the definition. Each x value corresponds to exactly 1, to only one y value. So coming back to our second example, do you think that the second example is a function or not? No. We call this a relation. It's possible, but it's not a function. Still, the first set is called domain, and its second set is still called range, but it's not a function. It's a relation. Okay, let's look at the third possible scenario. Is the third possible scenario a function? Perfect. It is a function. It's an f of x. Why? This x value corresponds to only one y value. This x value corresponds to only one y value. This x value corresponds to only one y value. Great job. What if I'm given some graphs? Can I identify whether they represent functions or not? So let's take a look. Here's a graph. Here's another. Here's another. And here's one more. How will I know whether, when I look at a graph, how will I know whether this is a function, the graph represents a function or not?
There's something called the vertical line test.
By the vertical line test. Excellent. So not here or here, that would mean nothing, right? There's outside of the domain. But here, when I draw a vertical line, I see that it crosses the graph in 2 points, and I will be reading two y values. This is exactly like this. For one x value, I read two y values. For one x value, I read two y values. So it's a relation. The circle is not a function, or the ellipse, whatever I graph there. So relation. What about this one? By the vertical line test, I read only one y value for each x value. By the vertical line test, I read only one y value for each x. So this is a function. What about this one? Function or not? Very good. What about this one? Function. This one we graphed last time. What kind of a function is this? Very good. Awesome. Linear function. Great job. Any questions? Any questions? Yes? Any questions? Okay, I would like to look at a few graphs. I would like you to choose. I would like you to choose a graph from here, any graph you'd like. Because we would like now to understand and identify the domain and range and read from the graph. Which one? Let's start with 82. 82. Let's analyze 82. Okay. So I see this function starts at this point, and we can say it decreases. The trend is decreasing to this point. Would you say that? Would you agree with my explanation or interpretation of the graph? Okay. So now look at the domain. Domain is measured on the x-axis from the leftmost point of the graph till the rightmost point of the graph. Well, I see that this graph is somewhere between -6 and 0. Would you agree? There's nothing outside of -6, 0. Not to the left and not to the right. Agreed? This is an open point. So that point does not exist. The function gets closer, 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 closer to it, but it does not take that point. It does not attain that point. So what would you say the domain of this function is? What x values can I plug in? Well, I can plug in anything between -6 and 0, because if I cross it at -5, I will read y value. If I cross it at -4, I will read y value. If I cross it at -2, I will read y value. So I can only read a y value for this function only between -6 and 0. Would you agree? Agreed? Okay, what about range? Range we read from below to above, from small to large. For x, we read from left to right, but for the y values, from small to large. So now I look in a different way, from the right-hand side if you want. I see the smallest y value is at -3, and the largest y value is at 4, but not attained. This is an open point. So let's write domain and range for now, so I don't forget. So 82, I'll come back to that on page 331. I know you cannot see, but I'm just going to write it and I'm going to open it in a second. So it's -6 to 0, and the range is between -3 and 4, as you told me. Now let's go back, because we're not done with this graph just yet. Okay. Now, if I ask, does this function cross the x-axis? Does it have an x-intercept? Can anyone read the x-intercept? Even if it's an approximation, it may not be perfect. Can anyone read the x-intercept?
Sure.
Comma? Excellent. Excellent. -4, comma 0. Can anyone read the y-intercept?
Is it 0?
Excellent. That's why you said 0 first, right? Because it's the y-intercept, and it has to have 0 for x. Very good. So -4, 0, 0, comma -3. Excellent. Now here's the question. I would like us to determine, we already determined that. I would like us to determine f of -2. Approximate. How would I determine f of -2?
Minus 2.1 or something like that.
Correct. So I draw a vertical line at -2. F of -2 means x is -2, and we know x equals -2 is position. Position, right? X equals -2. It crosses somewhere here, and I read -2 point whatever. I agree with whatever you give me. -2.2.
It's not exactly on there.
Say it again.
It's not on the point to be -2 exactly.
No, it's not. It's further down. -2 would be here, but it's not. What if I ask you now find x when f of x is 2? What am I giving you now?
It would be -5.
F of x is 2.
The y.
F of x is 2 means when y is 2, it crosses the graph at this point, and we will be reading the x value, -5.2. Very good. So you understand there are two different questions here. So let's write down everything now. So the domain in 82 is between -6 and 0. Pay attention to this symbol and this symbol. This shows that the point -6 is not attained, it's a parenthesis, and this one is. The range is between -3 because there was a full point. At -3 is a full point, but at +4, it's not a full point, but it's an open point or a hole in the graph. Then we said that x-intercept, you gave it to me as -4, comma 0. Then you gave me the y-intercept as 0, comma -3. These are not intervals. These are points. And then you said that f of -2, I think it was, yes, is -2.2. And then we said when f of x is 2, how much is y? How much is x? And we determined was -5.2. Correct. Very good. Any questions on this? Any questions? Now, I would like us to review how to evaluate a function. That's very important. And what we see in a function when we are given a function to evaluate. Any questions on this problem? Do you feel like going through another problem like this, or is this good enough? I need help to decide. Do we need another example, or are we okay? Okay? Okay, perfect. So then let's just take a look at, you can always stop me if you need another example at any point in time, please. Okay, So evaluate functions. Very important. I'm sorry. It's still in 2.1. So we're looking at together 2.1 and then 2.5. So we're still in 2.1. Let's suppose I have this function. And you want me to evaluate it for 1. Find f of 1. You give me this function and then you say find f of 1. Okay. So here's what I see. When I look at this function, this is what I see. I see the pattern that the function is giving us. The pattern is 2 times blah minus 1 over blah minus 3. Blah can be anything. It can be 1. It can be x plus 1. It can be 5a. It can be 1500. It doesn't matter. This is the pattern. That function is all about. That's the pattern. 2 times whatever minus 1 over whatever minus 3. When I'm asked to find f of 1, I'm actually told blah blah or whatever is 1. And you have to fill it in everywhere. So if I ask you, and I will, to fill in x plus h, then you will have to fill in x plus h everywhere for the pattern. And you have to combine my terms, distribute, blah, blah, blah. In this case, we have f of 1. So in this, that's much easier. It's 2 times 1 minus 1 over 1 minus 3. So then the answer at the top is 2 minus 1. The denominator is negative 2. The top is 1. The denominator is negative 1. So the answer is negative 1/2. Can anyone give us the ordered pair that we just determined for this function?
Is it
Yes?
1?
Comma? Excellent. Excellent. The x value that was used was 1. The y value, which is the outcome, the result, is negative 1/2, of course. What if for this function I ask you to find f of 3? So please calculate f of 3 and tell me the answer. And the answer is?
Undefined.
Excellent. Thank you, Bob. 2 times 3 minus 1 over 3 minus 3 is, I don't care about the top. The denominator is 0. Let's write a note. Division by 0. The correct answer is it does not exist. Instead, we like to use this fancy word. Division by 0 is undefined. What it means is there is no number. I can't give you a number. There is no such thing. Division by 0 does not exist. We cannot come up with a number. However, what if I divide 0 by 5? So I have $0 in my pocket and I pick 5 of you to share my 0 with. How much would you get? Nothing, right? So 0 divided by 5 is 0. But 5 divided by 0 is undefined. So please keep that in mind. I would like us to pick a problem to illustrate what I just mentioned a second ago. Let's say I'd like to pick 30. 30, and then we'll move on. So 30 on page 230, and that is g of x equals x squared minus 10x minus 3. We're asked to find g of negative 1. We're asked to find g of x plus 2. We're asked to find g of negative x. Do not do anything just yet, because before we work on this problem, I would like this. Maureen, go ahead, please.
I have a question.
Yes.
So you said 0, 45 is 0, 5 over 0 is undefined. Why is 5 with the exponent is 0?
What is what?
5 with the exponent is 0. Why is that?
Very good question.
What was the question?
Here's the question. I'll tell you in a moment. Maureen has this question. She said, if 5 divided by 0 is undefined, how come that 5 raised to 0 power is 1? Well, there is no connection, but it doesn't matter. I need to respond to this question. It's a very good question. Okay. Forget about it for a moment. Do you agree that 5 to the third divided by 5 to the third is basically 125 over 125, and this must be 1? Would you agree with that?
Yeah.
Okay, forget about this. I'm just going to cover it. And I want to go this way. When we divide exponential notations with the same base, we copy the base, and what do we do with the exponents? Agreed? So the exponent will be 3 minus 3. 3 for the top and 3 from the bottom. Correct? How much is 3 minus 3? So this is 5 raised to 0. But we have established from the very beginning that 125 over 125 is 1. So therefore, 5 raised to 0 is 1. It's a very good question. However, I also have to make a comment. 0 raised to 0 is not 1. So a raised to 0 is 1 always, except when a is 0. So as long as the base is not 0, and we raise it to 0 power, we will always get 1. Very good question. Is this clear? 0 raised to 0, you have to wait to take calculus. Actually, tonight, if you want to stay, you're more than welcome. I'm doing, this is one of the 7 indeterminate cases. So tonight from 6:30, I'm working on these indeterminate cases with my calculus class. You're more than welcome in this room. But this is an indeterminate case. It's not 1. Okay, coming back to our situation, I'd like to go through this. I know what we're doing. I did not forget. We're working on this. However, I would like us to sign our agreement now. You're not giving it to me. It's an agreement between me and you, and you keep the agreement. I would like us to discuss this only because at almost every level of math that I teach, I have at least one student who is asking me constantly, how come that a plus b squared is this, and how come that a minus b squared is that? And I want us to establish it from the very beginning and not have to, of course I'm going to answer any question you ask at any point in time. But I hope that moving forward, we understand this and we put it aside and we know it forever. Okay. So the first question here is a plus b squared. And let's say I have no idea what this is. This is the last time I would like us to say I have no idea what it equals to. But I know that a plus b squared is nothing else but a plus b times a plus b. Would you agree with this step so far? then I will have to distribute or FOIL, right? A to A, and I get A squared, A to B, and I get AB, A to B, and I get another AB, and then B to B, and I get B squared. Because I have two terms that are identical, when I combine like terms, I have this. So the answer for this binomial squared is a squared plus 2ab plus b squared. And please write somewhere that a binomial squared is a what? When we square binomial, how many terms do we get?
Trinomial.
Thank you. So a binomial squared is always a trinomial. If we don't remember this moving forward, and you still write this, I'm not saying you will. If you still write this, is a terrible mistake.
Question.
Yes.
Sometimes the little term drops out and you don't get a trinomial.
Impossible.
No.
Unless maybe there is some square root in there that will cancel
right.
with something. Who knows? But if it's a binomial, when you square it, initially, you have to get a trinomial. No questions about it. No question about it. Can anyone give us the answer for the second one without calculations?
Is it the same thing instead?
Of course. Of course. Of course. Very good. Still a trinomial, but because the middle term is negative, then the middle term will become negative in the trinomial. And the last one, let's FOIL it for now. So a plus b, a minus b. I FOIL and I get a squared and I get minus ab and I get plus ab from these two and minus b squared. This time, these two are opposites. So then they cancel out and we get a squared minus b squared. But this is not how I need to remember these. So let's go back for a second and analyze how we need to remember them. Here's how we need to remember them. Not a plus b everything squared. You're not going to get a, you're not going to get b. It could be 2x minus or 2x plus 3y, right? So first term plus the second term squared. First term plus the second term everything squared is the first term squared plus 2 times the first times the second plus the second term squared. This is how we need to remember it. I want you to move away from FOILing these special products. Why? Because we're going to get to factoring. And we're going to have difficulties with factoring. And this is a document that I give to my students when we work on factoring. So when we get to this, very soon I hope, we're going to have difficulties if we continue FOILing that. Okay? Thank you. Okay, so these two. So then now, knowing that, let's go back to what we're trying to do. So this is our agreement moving forward, which means that when we talk about any binomial squared, you will give me 3 terms. If it's a sum or a difference, it doesn't matter, positive, negative, but you're going to give me 3 terms. And when we multiply 2 binomials that are identical except the sign in between, you're going to give me the difference of squares. Agreed? Perfect. Excellent. Thank you. Okay. So this was 5, 6, 6, 7. So now we are here. If you ask me, and I'm going to copy it again because I wrote a few things there. So this was g of x. X squared minus 10x minus 3. Of course, this is what I see. minus 10. This is the pattern. This is what I'm working with. So then, the first one is negative 1. So g of negative 1 is negative 1 squared minus 10 times negative 1 minus 3, which changes into negative 1 squared, which is 1, negative 10 times negative 1, which is positive 10, and then 11 minus 3, which is 8. And if you want, please give me the ordered pair.